My name's Josh Chisholm. This is my attempt at my assignment presentation 1 for SIT194. I've chosen to do it on week 4's topic of L'Hopital's rule and gone to answer question 2, which is explain L'Hopital's rule and give examples of where it can and can't be applied. So I'm going to have a crack at explaining L'Hopital's rule and just show a couple of examples where you would and wouldn't use it. So here goes. So L'Hopital's rule is used for calculating limits involving indeterminate forms, such as a fraction that would be 0 over 0, or something that would be infinity. The reason it's used for evaluating these intermedials is because if you were to look at a fraction, b over c would equal a, which would lead to b equaling a times c, and a could be anything, so that would leave us with something that's indeterminable. So when we have a numerator and a denominator that are both 0, we can use L'Hopital's rule to differentiate both and then take the limit. So L'Hopital's rule is as follows. We take the f of a and the g of a both equaling 0. We then put that into L'Hopital's rule. So the limit is, as x approaches a, f prime x over g prime x. As it approaches the limit, we just substitute the x for our a, so f prime a over g prime a, and then the equation looks something like this. So we've got the limit as it approaches a, we take the f of x minus the f of a, and we divided that by x minus a. We then divide that by the g of x minus the g of a, and divide that by x minus a. So that gives us something like this. So we can use basic algebra to simplify that and just cancel a few things out. So if you can see on here, we're just going to cancel that x of a out and the x of a out there, because that applies in both areas. That then gives us this equation here. So we're just looking at the top line. So the f of x minus the f of a divided by the g of x and the g of a. So going back to the very beginning, when we said the f of a and g of a equal 0, because they equal 0, we can also just rule them out, which gives us something much easier. So by applying the limit, we can get the f of x over the g of x and use L'Hopital's rule from. So one example of where we wouldn't need to use L'Hopital's rule would be something like this, where we can already derive our limit. So here I've made the limit as x approaches pi. So we've got sine 2x over x. So obviously sine 2x equals 0. X is our pi, so the answer is going to be 0. So we wouldn't apply L'Hopital's rule for something like that. However, something like this, so our limit as x approaches 1 of, say, ln x over x squared minus 1, that would equal 0. And here again, because we're x squared minus 1, that gives us 0 again. So we could apply L'Hopital's rule to something like that. So taking that as a limit of x approaches 1, that would give us 1 over x over 2x, and that's quite easy. Those cancel each other out, and that would just give us 1/2 as our limit. So that's a good example of where we would apply L'Hopital's rule. So I also wanted to show an example where L'Hopital's rule can be applied twice. So for instance here, where x is approaching the infinity limit of x squared times e to the minus x. So because you've got infinity times 0, as x is approaching infinity, we're going to get infinity over infinity. So that proves we can use L'Hopital's rule. So the first one obviously doesn't solve it, so you can apply L'Hopital's rule to the derivative from this, which gives us 2x. X squared becomes 2x. Ex can't be derived, so it's ex again, which gives us infinity over infinity, which means we can apply it for the second time. The derivatives of 2x is 2 over ex, and as e is approaching infinity very quickly, that's going to equal 0. And then finally, just to reiterate, L'Hopital's rule cannot be used on quotients which are indeterminate. So for example here, we've got as x approaches 3, x squared minus 1 over x minus 1 gives us 9 minus 1 over 3 minus 1, which is 8 over 2, which equals 4.